Hello everyone, today I want to do some reverse engineering on some malware that exploits DirtyCOW. So I have it open in Ghidra here, and I'm just going to now do a quick analysis with the default settings. Once that's done, I'm going to go down here and search for main, which we're luckily enough to have here. And so right at the top here, you can see that main is not properly defined. So let's go ahead and do that real quick. Main returns an integer. This is going to be argc. So the argument count, and then this long param is actually not a long at all. It's actually a char pointer or a char array, which you can display doing this in Ghidra. And we're going to do argv. So we're going to do OK. And now that that's defined, you can see it defines some local variables here. And then it makes a copy of the password file. So I'm just going to call this result, or copy result. And if that fails, it just exits. So otherwise, it checks to see if any arguments were passed. If there wasn't any arguments passed, it prompts the user to put in a password. So we're just going to rename this to password. Otherwise, it grabs it from the argument list. So now what it's going to do is it's going to generate a password hash by using the crypt function. So I'm just going to rename this to password. And this root right here is actually the salt. So we're going to go back. And then once that's done, you can see it does this generate password line. So what this actually does is it generates what you actually see in your etc password file, aka this stuff. So nowadays, passwords are located in the etc shadow directory, but before you could find them in password-d. And I think it still works if you put them in there, but it's just like outdated. Then it returns that, so I'm just gonna say password line. Go back, and I'm gonna rename this to password line. And then it's going to print it out, and then it's going to open the password file. So I'm just going to rename this to password file. It's going to fetch some stat information on it. So then down here, this mmap is called, which basically just maps our password file in memory. Then it just checks to see if this thread was already running, and if not, it starts this my advice thread. So what this thread does is it calls my advice on the memory map we had, and what it's basically doing is it's saying that, hey, we don't need this anymore. Trust me, okay, I'm not going to do anything. I'm not going to write to it, And it does that, a ton of times, and it just keeps doing that over and over and over again. And once that thread is done, which it waits here, it calculates the length of our password line. So I'm just going to say password length, and then it takes our password length again, and it looks like it converts it to an integer, and it uses the same variable as the copy result. So I'm just going to rename this to I password length. And we have some counter variables here, so I'm going to rename this one to I. Another one, I'm just going to rename this to J. And another one, I'm just going to rename this to G. So here with ptrace, essentially what this is going to be doing is we're going to be writing to the map file that in the previous thread where we said, hey, we're not going to be writing to this. We're going to be writing that password line over and over and over again. This is essentially going to cause a race condition, which is going to allow us to gain write access due to copy on write. Ptrace returns how many bytes it written, so I'm going to say written bytes. And I'm going to rename this local to total bytes. So now to kind of go over this from top to bottom real quick again, if we scroll up to main, it's going to create a copy of the password file. If that fails, it's going to quit. Otherwise, it's going to check to see if we provided a password. If not, it's going to prompt us for one. Otherwise, it's going to use the one we provided. Then it's going to generate a password hash for it, create the password line for the etc password file. Then we're going to open the password file and create a memory map version. We're then going to start this thread down here that basically says, hey, we're not going to write to this map. And then we write the password to the password map over and over and over again for the size of the password, essentially trying to create a race condition that grants us write access. Then after that, all of this debugging information is printed out. And if we actually throw this into VirusTotal here, you can see that it actually detects it as DirtyCOW. You can see this the CV number and a lot of flags. So I hope you guys enjoyed. If you want me to take a look at anything, please let me know.